Hello, so continuing on problems from weekly contest 344, the second problem, frequency tracker. So basically with this problem, we want to design a data structure that keeps track of the values in it and answers some queries regarding the frequencies of values in this data structure. And so initially we initialize it with an empty array, and then we have three functions: one to add a number to this data structure, the other one is to delete an element, one occurrences of this number, and then the other one is to check if there is frequency, if there is this frequency in the DS data structure. So remember, we keep the frequencies of elements. So let's say we add we call add for 2 twice, right? And then we may get a call with has frequency of 2, and we want to return true in that case, right? So that's sort of the idea here. Now, if we take a look at this first example, so you can see here we get first add for 3. So the frequency of 3 would be 1. Then another add, so the frequency would be 2. And then we want to check if there is this frequency of 2. And yes, because we have 2 3s. And so we return true. So that's the idea here. Now, how do we implement it? Okay, so let's see how we can do this. Well, we know we need the occurrences of a number data structure, right? So that just records how many times a number occurred. And then the other thing, to be able to easily answer the has frequency function. So the constraint says that that function, the combination of that function add and delete, they all will be called 10 to the power of 5, right? So that means we can't, for has frequency, we can't actually just do a loop on occurrences, because this one would be also of, let's say this is n. This one will also be O of n, because that's how many times we call all of them. And so if we call add all the time, then it can be up to 10 to the power of 5. And so if for this function we call it as many we traverse the entire occurrence map, so O of n, then we may end up with the O of n squared solution, and that would be too big. And so we need a way to make has frequency faster, right? For the other solutions, let's say for add and delete, it should be easy, since for the occurrences, we just say occurrence, for example, of 5, we increment it by 1, and then when we want to delete it, we decrement it by 1, okay? So the add and delete we can do in O of 1, but we need a way to do has frequency in less than O of n. So instead of just traversing and checking for each element if it occurred the frequency of times, we want to find a faster way. So what's a faster way? Well, let's just try to do another map for frequency. That way, if we have another map for frequency, that way if we get a call for has frequency of 2, we can just check if this is bigger than 0. If it is, that means we have that frequency, okay? So basically what we can do here is just maintain 2 maps, one for the occurrences of individual numbers, and another one for how many times a frequency is in this occurrence map, right? And so let's have another frequency map here, okay? And let's see how we can update them. So let's say first we get a call for add with 3. So in that case, we just want to say that now we have 3. Let's say we have, but we want to also update the frequency. So how do we do that? Well, we want to say that now we have an element, we have a frequency of 1, okay? And now let's say we get another add 3. Then we want to update this to 2. But when we update this to 2, we want to say we no longer have a frequency of 1, right? So we want to say that this is now 0, but we have a new frequency of 2. Sorry, this is 1, okay? So how do we do this operation? Well, for occurrence, it's easy. So this is the add operation. So for add occurrence, it's easy. We just say occurrence of that number, right, plus 1. But for frequency, so this is the new frequency. This is 2 in this case, let's call it. So let's call that f, the new occurrence, okay? So we know that we want to increment it by 1, right? And so we want to say the frequency of f, just increase it by 1. But also, in this case, it was 1, but now it becomes 2. So the frequency of 1 should, the value of the occurrences of frequency 1 should decrement by 1. And so we want to say that the previous frequency, which in this case, because we just added 1 to the frequency, is just f minus 1, we want to say that this is -1, right? Because maybe, let's say we added 4 previously here, right? So let's say we added 4 previously here, then this would have been 2, and then when we add 3, since this becomes 2, we want to decrement this to be 1 to just account for this occurrence, right? So that's why we do f-1, because f-1 is just the previous occurrence before this incrementing, okay? So that should solve for add. Now, what about has frequency now? Well, has frequency is now easy because we can just say, so let's say with f, then we can just check this map, right? So we can just check if the frequency ff, if it is bigger than 0, that means it's here. There is a number that occurred that many times, okay? So we just want to say if this is bigger than 0, then we can return true, okay? Now, what about delete? Now, delete is a little bit, so let's say here we want to delete, after getting this add of 3, we want to delete 3. We get delete 3. What should we do? So if we get delete 3, that means we want to decrement this count, okay? And then we also want to say that now the frequency of 2 no longer exists, right? So we want to decrement it. And so we want to decrement it to 0 here. And then we want to say that the new frequency increased by 1. And so the new frequency is 1, so we increment it. Okay. So how do we do this in code here? Well, first we want to say that the occurrence of the number decremented by 1. Okay. Now the new frequency, right, incremented by 1. So the frequency of f should increment by 1. But what about the previous frequency? What is the previous frequency? So we decremented by 1. So the previous frequency is f plus 1. And we want to say that it no longer, that we just removed it for this number. So we want to decrement by 1. And that's pretty much it. So you can see with these operations, this is O of 1, this is O of 1, this is O of 1. Okay, so all the operations are O of 1, so it's just the time complexity will be just the number of calls. Let's call the number of calls k, then it would be O of k overall for the data structure. So this should pass fine. Now space, of course, we have these 2 maps, so it's O of the number of calls space. Okay, yeah, so that's pretty much the idea here. Now let's just code this up and make sure it passes. Okay, so let's implement the solution we just saw in the overview. So what do we need? Well, first we need to initialize the 2 maps that we need. So we need one for the occurrences. So this is going to be just a map. We want to use a default dict so that initially all the values start at 0. And then we want a frequency, which is also just a map of int values. So that would be something like this. And then here we want to increment, so the occurrence of number should be +1. Okay, just the logic that we did in the overview, and then let's actually just copy it since we already saw it. So we get the frequency, we increment it by 1, and then we decrement the previous frequency. And we do a similar thing for delete, right? We remove the occurrence, we update the new frequency by 1, we decrement the previous frequency, which is f plus 1. But for delete, there is one condition that we want to do, which is the problem says that if the element is not in the data structure, we just want to do nothing. So we want to do that check. So how do we check if an element is in the data structure or not? Well, if it is there, then its occurrence would be bigger than 0. If it's not there, then it would be equal to the default value of 0. And so we want to just check that it's there, that it's bigger than 0. And now with this, so we check if bigger than 0, then we do this. And then to check has frequency, we just want to return that frequency of this value is bigger than 0, right? So pretty straightforward there. And this should pass. Looks good. Let's submit. And that passes. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.